is just given to us as an equation. So if you think about it, and we will graph it on your calculator, it's not going to end at all like the previous one did. In fact, it is going to have arrows on it. And just for the sake of having a visual in front of us, which I highly recommend, I would like you to sketch a graph of it. But when we look at this, and you're going to go to your y equals, you're going to type it in. And again, I want everybody doing this and on the same page. If you lose me at any point, put your hand up so I can slow down. But stay with me. Type that in. When we start looking at a graph, you should probably start with like your Zoom 6 standard -10 to 10 window. But just to review what we talked about yesterday, what's the y-intercept of this without having to do much work? -3. Very good, Chris. It's just your C value. So if that was -300, we would have to change our window for sure. But -10 to 10 should cover it. So I'm going to hit Zoom 6 just to make sure it's all, so we'd all be seeing a similar thing. Now, we know we're going to be asked for when is this increasing, when is this decreasing, when is this positive, when is this negative. So some of the key points are always going to be your x-intercepts. Now, how do we find those on a calculator? Anybody know? Didn't we just do this yesterday? Some people said the table, and in a lot of problems that works, but in a lot of problems that doesn't work. So I want to find the method that works no matter what. Chris? Second trace, very good. And which option? Zeros, yep. So you want to find your zeros. So we're all going to practice what I showed you yesterday. And I'm going to find this left zero first. So when it asks for the left bound, I need to scroll left and get my cursor to the left of that intercept. And it's still blinking there. And once I get it there, I'm going to hit enter only one time. And at the bottom of the screen, it now says right bound. So I want to bring my cursor to the right of that zero. And this calculator is nice because it's kind of got that vertical line for me to kind of prove to me that I am to the right of that intercept. Hit enter. Guess means nothing. We have a 0 at -1. Okay? So -1, 0 is a point that's going to be of interest. I'm just going to cheat for you and tell you that the other one's at 3. Your y-intercept is important simply because they're going to ask for it. The x-intercept they're going to ask for, but they also want positive and negative, so that's critical for that. So for the y-intercept, this point, how do you suppose we find that? The y-intercept occurs when what equals 0? What coordinate is 0? The x. The y-intercept is when the x-coordinate is 0. The x-intercept is when the y-coordinate is 0, so it's kind of flip-flop like that. So again, our favorite menu is going to be this trace menu, second trace. And option 1 is value, which allows you, if I just hit enter on that once, what it allows you to do is name your x-coordinate, and I'll tell you the y that goes along with it. So if I want the y-intercept, I can just plug in an x of 0 coordinate and hit enter, and boom, there it is. It's going to put your cursor right there. It's going to tell you that your y-intercept is at -3. Okay? This one seems a little bit bizarre to do this with because they're all whole numbers and you could probably count them out. But guess what? Most functions aren't going to be that pretty. They're going to be weird, crazy decimals. So label y-intercept 0, -3. And what other point on here do you think is critical? The minimum. Yep, any turnaround point, because guess what happens here? It goes from decreasing to increasing. So we're going to need that kind of shift of events. So the minimum, second trace, again, that second trace menu is our go-to. This particular vertex is a minimum. Hit enter once, and again, it's going to ask us for a left bound, right bound. Go to the left of your minimum, which my cursor happens to already be there because I left off at my y-intercept, enter. And then it's going to say go to the right of your minimum. So scroll right, scroll right, scroll right. Make sure you turn that corner. Hit enter. It's going to say guess again, hit enter, and bang, it's going to go right on that vertex. Okay? Now, it's the pixels on your calculator. It's the lack of quality. It's not a true computer. It's a baseline computer, essentially, is what your calculator is. So you see how that minimum coordinate at the bottom says 0.9 repeating and then -4? Sometimes, does anybody else say 1? Yes. So it depends on some setting. I'm not really sure exactly where it is. But when you see that, for all intents and purposes, that's just 1. Okay, you don't need to write 0.9999999. Clearly it's repeating forever. So, oh no, it says 989 at the end. So it's a pixel thing. It's just 1. So 1 -4 is going to be your vertex. And then we can come up with a nice sketch. And yes, my graph gets cut off, but that's just because my window is been set. This is going to go for certain to infinity. Are we good there? Any questions on that? Okay, so now our increasing interval. Jack B, what do you think it is?
1 to infinity.
Very good. From an x-coordinate of 1 to infinity, it's increasing. Increasing, decreasing, and constants always use parentheses, so that's a discussion we don't really need to have. Eric, decreasing.
Existent.
Say it again.
There's no decreasing or no?
Decreasing means a negative slope. There's never a negative slope on this thing. There is, isn't there? Negative slope means as you're tracing the graph from left to right, it's going down.
Negative. Right. Negative infinity to -1.
To positive 1.
Positive.
Yes. So it is decreasing along this entire stretch. Negative infinity to 1. There is no constant interval, so I'm just going to write nothing there. How about domain? What do you think, Angie? So the graph only exists from here to here, from -1 to 3. Nothing exists outside of those vertical lines?
Would it be negative infinity to infinity?
Perfect. Negative infinity to positive infinity. Good fix. Range. What do you think about the range? Sierra with a C. What's that?
0 to infinity.
So from 0 to infinity, the graph doesn't exist below that at all? Does the graph exist below? Perfect. Does everyone see that? -4 to infinity. Really, the range is the only time we look at the y-axis, truthfully. How about parentheses versus brackets here? Morgan, what do we need? On both of them? On the -4 and the infinity. Well, I'll tell you what, you're right about the infinity because that always gets a parenthesis. But the -4 needs a bracket because it actually does reach that level, right? If this was an open circle at the very tippy bottom, no, you normally say tippy top, tippy bottom. At the very, very bottom, if that was an open circle, we'd use a -4 with a parenthesis, but because it is a point that's actually on the function, we go with the bracket. Okay? Positive tests. 3 to infinity. How about brackets or parentheses on that 3? Correct, because positive means above the x-axis. Is 3 above the x-axis? No, it's not. It's on it. Good. We're missing a section, though. There's another section where it's above the x-axis test. Well, -1 to infinity would suggest starting at -1 and moving to the right, it's always above the x-axis. That's not what you meant, is it? It's not above the x-axis right after -1, is it? It's below the x-axis right after -1. It's prior to -1 that it's above the x-axis. So you want to go smallest to biggest anytime you're doing interval notation. Help her out, Lucas. Other Lucas.
That's infinity of -1.
Right, negative infinity coming from the left up until -1. Do you follow that? Left to right. By the way, as I'm going around the room right now, it's not that I want you to get it wrong, but I want all these mistakes to come up so that I can address them. Because this is an easy concept, but it's also very finicky with notation and stuff, and it can mess with your head a little bit, so it can become pretty difficult, shockingly. These are all very common mistakes that I'm purposely digging out. Yeah.
Why would that negative
Oh.
be?
It's not. I'm sorry, thank you. This was a continuation of over here. My bad. Negative. Elena.
-1 to 3,
Very good. Parentheses, brackets.
parentheses.
Very good. Did I give you guys back your tests yet? Okay. I have those. Don't leave today without them. Okay, relative minimum point. So you're looking for like a vertex of sorts, some sort of turnaround point. Anywhere it goes, and here's a good rule, anywhere it goes from decreasing to increasing is a relative minimum. Anywhere it goes, if it ever was increasing first, we'll look down at number 4 quickly. If it's increasing first and then decreasing, any place where that transition happens, that's going to be a relative max or min. Not necessarily the absolute, but it will certainly be a relative. So your relative minimum point, and they're looking for coordinates here, 1, -4. Do you see what can be tricky about interval notation versus the notation we use just to identify a point? This particular one does not mean from 1 to -4. Does that make sense? And this interval notation that we use back here does not mean anything having to do with the point -1, 3. So you almost have to know the context in which you're reading or listening to know what's a point notation versus what's an interval notation, because with parentheses on both sides, it could be either. Could be a point or it could be an interval notation. Chris, question?
No, I just figured it out myself.
Okay. There is no relative max point here because there's no place where it's going from increasing to decreasing. So that does not exist. The absolute minimum point, the lowest point on this graph in this case, happens to be the same as our relative minimum was. So that's 1, -4. Now, I want to talk about this quickly. Sometimes you won't be asked for the absolute minimum point. You might be asked for the absolute minimum value. And can anyone tell me what they think that would be? Absolute minimum value. It ties in with the same location. Yep.
Y equals
-4. Yep. You actually, and that would be the other time other than the range where you actually look at the y coordinate. The absolute lowest value, the y value, is what they're talking about because they're thinking lowest, is -4. Yep.
Why do they have parentheses and no brackets?
Here,
Yeah.
because this is just a point. This is just going back to pre-algebra, like the way you identify a point and a location is with 2 parentheses. This is not interval notation. Does that make sense? Absolute maximum point. It's going up and up and up to infinity. There's no way to quantify that. So that does not exist. There is no absolute maximum. And then our x-intercepts are just at -1 and 3. We're just listing those. Those are not interval notation questions. They're not point questions. Although you could write them as points. You could write -1, 0, and 3, 0 and write them as points. I just listed them. And the y-intercept, of which I should only have one, is -3. Okay? Any questions on this? Okay. Number 3 also gives us a function, but it limits it for you. It tells you it only wants you to look at this from -5 to 5. Not only that, but do you see how it's -5 is less than or equal to x versus x is less than 5? One of them uses the or equal to and the other one doesn't. That means this endpoint at -5 is going to be solid. This endpoint at +5 is going to be open. Other than that, we're going to do the same thing. We're just not putting arrows on the end of this one. So I'm going to sketch this same way I did on the previous one. And I don't need to multiply that out. I can type it in just as is. Can anyone tell me just by looking at that function what the x-intercepts are going to be? Say it again, Chris. 3 and -4. That comes from teeing it up. So you can get those right on there if you want. 3, 0. -4, 0. Is it going to open up or down? Is it going to be a positive x squared or a negative x squared? If you were to multiply it all out. Positive, so it should open up, and we'll just take a peek here. So, obviously it's got a y-intercept that's lower than -10. Because this doesn't have the c value just popping out at you, you can't just look at this and know what the y-intercept is. But you can plug in 0 for your x. And if you do that, what's 0 minus 3? -3. What's 0 plus 4? 4. 2 times -3 times 4. 2 times -3 is -6. -6 times 4 is -24. So the y-intercept is going to be -24, which means I'm just going to change my window. So my window, I'm going to change my y-minimum to like -25, and I like things centered. So I'm going -25 to 25 on my y-axis. I'm fine with everything else. I don't mind the x being -10 to 10. Beautiful. Now, if I didn't do that mathematically in my head to find the y-intercept, that's the second trace. Value, x of 0. Beautiful. It gives me 0, -24 at the bottom. So I'm going to sketch that. We also said we really, really, really want the minimum, right? That's a critical point because it's going from decreasing to increasing. So second trace, scroll down to minimum. Uh-oh, I accidentally hit a bad button. Minimum, enter. So get my cursor left bound. So get my cursor to the left of the minimum, there. Get my cursor to the right of the minimum, there. And I get, okay, again with my pixel. My y coordinate is fine, -24.5. My x coordinate, what should I round that to? -0.5, exactly. -0.5, -24.5. And then I think I have enough, except for remember, I don't want arrows at the end of this. I want a solid dot at -5 something and an open dot at 5 something. And again, if I want those coordinates, which I do, I'm just going to hit second trace and value. If x is -5, what's my coordinate? 16. So -5, 16 is that endpoint. And on the other side, second trace, value, if I type in x equals 5 there, I get 36. So 536 on that end, and that end is the one with the open circle. Yep.
How did you find the -4, 0, and the 3, 0?
I could have done second trace and zeros. Those are my roots or my zeros or my x-intercepts, and then left-bound, right-bound on those. But to be truthful, we knew that those were the x-intercepts, so you set y equal to 0, and you pretty much just teed it. We teed it up. We actually did it mentally. Okay? All right, so increasing. Oh, boy. Vince. What do you think? From where to where? -0.4, you said? Okay, but you're giving me y coordinates. And we want to know it's increasing from where on the x-axis to where on the x-axis. Very good. -0.5 to 5. Common mistake. Always parentheses because it's increasing, decreasing. Decreasing interval. Let me hear from Sierra with an S. -5 to -0.5. Very good. Owen. There is no constant interval, so I'm going to have you jump to the domain. Very good. And tell me about parentheses and brackets. Not on both of them.
-5 should be in parentheses and 5 should be in brackets.
You've got that flipped. Brackets means you want to include it. We want to include the -5. We don't want to include the 5. The range. Oh boy, I'm just going back. Olivia. Okay, for the range, this is the one time you look at the y-axis. Lowest point reached on the graph to the highest point reached on the graph. And you're looking at your y coordinates here. Can you go up to the screen and point to the lowest spot this graph gets to? Yes, and that actually includes that because it's solid down there. There's no open circles, so that's a bracket. And then what's the highest y value this ever reaches? Or tries to reach? I see a y coordinate over here that's 36. 36. And that 36 is not included because it's an open circle. So again, the range, that's the one time. Good job. Thanks for struggling through that with me. Oh, I didn't know you were a lefty either. Who else is a lefty in here? Oh, well. Interesting. Positive intervals. Mike.
-0.5 to 5.
Negative. So from here to here, it's positive. You're confusing it with increasing. 3 to 5. Tell me about parentheses or brackets. So this point here you're telling me is above the x-axis? Right. That's a tricky one. So it is a closed circle, but it's not actually above the x-axis. And then this one's definitely open, so that's that. We got another positive interval. Help him fill that gap, Natalie. She said -4 to -5, which I know what she means. You always have to go smallest to biggest, so left to right. So just flip that. Does that make sense? -5 to -4. And what, Natalie, can you tell me about parentheses brackets, do you think? Perfect. Nice job. and a little union symbol between those. Negative interval, Mike? Oh, did I already call on you, Mike? I'm sorry. You don't want to do it again? Oh. Lucas Coletta.
From -4 to 3.
-4 to 3. Relative minimum point. Jason?
-0.5.
Yep. Good. Absolute minimum. Kate? Yep, same thing. Happens to be. It's not always, but it happens to be here. Relative maximum, there is none. Absolute maximum, this is a discussion. Sort of requires more thought than you would think. The absolute maximum point definitely draws your attention here. Yes? 536. The issue is that point isn't actually on our graph because it's an open circle. So the absolute maximum point is just prior to that. Like 4.9, 35.5, right? In that ballpark. The problem is there's no way to actually quantify that because then someone else could just say, well, maybe it's 4.999, 35.9999999. Believe it or not, there's an infinite amount of space and an infinite amount of numbers between this and this. You can get infinitely close to 536. The ideal answer would seem to be 4.9 repeating, 35.9 repeating. But we're not even sure, because that's an infinite number and that's going to carry on forever, we're not even sure that that would actually work on the graph. But it's something in that ballpark, we just can't quantify it. So the actual answer there is that there is no absolute maximum point, which is interesting. That's not the absolute, the graph gets above 16. So it's not the absolute highest point on the graph, so no. Does that make sense? We have our x-intercepts at -4 and 3, and our y-intercepts at, what do we say, -24. So your homework for tonight is going to be that same worksheet. Everything else except 3B. We still haven't really gotten to 3B yet. We'll talk about that tomorrow. So you're doing 4 through 7. Okey doke. Any questions? Cool.